Hi guys, let's continue with solving our tasks and let's go to the next one. So today we are working with Serialize and Deserialize binary tree. Serialization is a process of converting of data, structure, or object into a sequence of bits so that it can be stored in a file or memory buffer or transmitted across a network connection link to be reconstructed later. So we have to design such algorithm where we have our binary tree. We have to serialize it into the string and then deserialize from the string. Yeah. And we see that we have left and right node. We have our value. So, so how can we serialize actually our node? So to serialize our node, we can, for example, traverse by we can traverse and create some string, for example. For example, we can do BFS. So when we do BFS, we have 1 on the first level, then 2, 3 on the second level, 4, 5 on the third level. And actually we have every time 2 more elements. So yeah, so what we can do is actually do BFS, and when we own null, we actually return string null and construct string this way. And then when we get this string back, we can do BFS one more time. Like we parse our string till the end and connect for each node its parent actually. But let's think how to deserialize it. So for example, we serialize and we have string something like 1, 1, 2, 3, null, 4, 5. Yeah, let's imagine that we have such string. Then how we will deserialize it? We are going and create a node from the root. And then we pass this root to this one, right? And then we should take next element and pass to the next one, to the next two. Okay, and then we take 3 and create the root from this 3. So it will be left and right. Okay. Then we take this one and take another one, 2, and so on. But yeah, here with BFS we see that it's easy to serialize, but it's hard to deserialize. What if we will try to deserialize it with DFS, for example? So with DFS, what we do, we do, for example, in order. So it would be 2, 1, 4, 3, 5, right? And then we create like node from 2. Then node 1 with node 3. Yeah, and what if I will do something like 1, 2, 3, 4, 5? Then I will create node for 1 and iterate over 2, but I don't know like 3. What is actually 3 here? So yeah, it will be hard probably. So maybe we can indeed try to serialize it this way, like to create an array, and then we can go one by one. So this would be one level, another level, another level. But how to build these levels actually? So I can create node of 1, right? And then when I create node of 1, I go left and right. Yeah, so maybe I will like put into the queue 1, and then when I take this one, I should take the next 2 elements, 2 and 3, and move here. Yes, and now I have node with 1. I have 2. Okay, I have node with 1, so my left for 1 would be 2. So I take node with 2. And node with 3. Yeah, so Deserialize, it's really hard. It's really hard. I don't know, like for example, I can take 1, create node, I can take 1, create node of 1, and I have maybe pointer, and send this 1, and make maybe recursion. Maybe I can make recursion for 2, and then for 3, and then when I'm on 2, so first it's 1, then it's 2, 4. So when I'm on 4, on 2, and when I'm on 3, I should start with 6, so always plus 2, or multiply by 2. 2, Mm. Yeah, so maybe I can create like a tree node. Yeah, so I have this 1, 2, 3, node, 4, 5. So I take this one, tree node, and I have this Deserialize with 0. So I create tree node. Yeah, so I have with 0 and this data. For 0, I create tree node with 1 and call Deserialize for 1 with data and for 2 with data. So it would be recursive call. When I'm on 1, I should not take this 3, but I should take this one. So it should be like level also. So first I'm the first level, then I'm on the second level, which also would be second level. So when I'm on the second level here, I should take all elements starting from here. So like I'm on second level, it means I have like 2 elements, right? So it should be always multiplied by 2, multiply by 2, multiply by 2. So here, I mean, from 2 it should be next, right? So when I am on 1 first element, so I create, here I create 3 node of 1 and make another recursive call with of 1, and I will make another recursive call uh, 1 plus 2, and here it would be 4 and data. Here it would be 3 node of second element and a recursive call of 2 plus 2 and 4, right? Yeah, because 4 elements. So here, when I'm on 1 plus 2, 1, like 1, 2, 3, 4, 0, 1, 2, 3. Yeah, so I take this 3 as a left node. Yes. And also D. 1 plus 2 plus 1 for data. So also I should make a call for 1 plus 2 plus 1. So it would be 4. So this one. Then when I'm on 3, right here, so I should call 2 plus 2. Four, so like 0, 1, 2, 3, 4. Yeah, but it should be 5. It's not 4. Yeah. Okay, so only 1 multiply. Here 2 multiply. Yeah, Deserialize, it's really hard. It's really hard. 1, 2, 3, 4, 5. What if I will do not BFS, but DFS? So for example, I have 1, right? Then I go to the left. So I have 1, left, 2, back, right, 3, left, 4, back, right, 5. So I have something like this, and when I iterate, I check, okay, so when it's element, so that I create 3 node of 1. Okay, then yeah, if I created 3 node, then I iterate recursively, like to this 3 node, I should I should make recursive call from this position. Then I on this position, right? I make 2. Okay. Then I have B. If B, I just return it. Then I return from here, from left. Then I check, okay, if it's R, I go to R. L, for B, just return, then R5. Okay, so I think it should work something like this. So I need to create DFS with data and pointer. And in this separate DFS, I will check if it's value, and this value is actually, yeah, node val. The number of nodes in tree, and node val can be not one value. Okay. So yeah, we can even consider something like this. Like values would be inside these boxes, and this position would actually will get some returns. Okay. Okay. Again. Yeah, R. So I make recursive call for R, create, make recursive left call, create, B, just return, back here, and check R, create, and so on. Yeah, I think it should work something like this. So for serialize, what we actually need to do, here we need to do the following. If root is equal null, we return empty string. Okay. Otherwise, we take root val and create a value. This value would be under this things. Then, when we created this value, we can check if root left not equal null. We add to value L, and make serialize call with root left, adding this to our value. If root right, not equal null, we make r plus right. Okay. So in this case we have 2, right? So we have 2. We have nulls. So we have go back to 1. So after this we just make b and return null. Okay. So in this case we make our serialization. And as we see, we never call with null, actually. So maybe we even don't need this one. So I create 1, then I print L, call with 2, create 2, go back, create R, go to 3. Okay, so I think something like this. And here we can just return null, for example, and print its system out print ln data from it. Okay, line 15, root is null. Okay, what about this one? Okay, so I have 1 L, 2 BR, 3 L, 4 BR, 5 BBB. Yes. So my my data is correct. And what I'm doing now, so what I'm doing now, I create a private method with string node to called DFS. Here I have string data and integer pointer. So so what I'm doing here, so I have data pointer. So first of all, if pointer is equal to data length, I just return null. Not sure about this one, but let's check. Then I take data jar at let's say pointer will be I. Char at I. Char at I. Car char. If car, let's call it car, is equal to start of the value, then I iterate while car not equal to closer one, and I have value 0, and yeah, what I'm doing here, I take data char at, yeah, so what I'm doing, I++, then char at I, also I have multiplier, it will be 1, so we have char at I, minus 0, plus 0, and here I have value plus multiplier, then multiplier multiplied by 10, and I++, and yeah, so current Okay. So what I've done here, so current would be equal to data char at ++I. So it would be our next character. Currently I have my value, and if I have back, so I create my values, and if left, I go, yeah, DFS to left, okay, if then F2, yes, so I have my value. Have 3 node, null, Here I slice my 3 node with value then if current char is equal to L, then my node left, yes, will be equal to this DFS call with data and I plus 1. If car equal to right, then I have the C, but who is right? Okay. And if car equal B, then I just return my node. Okay, so let's maybe I don't need B. Maybe I should always return node. Okay, let's check. Return DFS data 0. Okay, so let's make this call for this string. All right, and I have pointer to 0. So this one. Okay, so I have current char. Then I take this current char. I initialize my value. I increment my current char. And yes, so while not equal to this one, I take this value. Yeah, so this one I'm not sure. So let's say that 0 is 27, right? And 1 is 28. So yes, I need to do something like this. Okay, and so I need to do something like that, and then multiply by multiplier. Then I increment my multiplier, go next, and check that it's closing one. So I create my new node, go to the current one, increment to L, check that it's L. So I go here with this one. And yeah, so I create new node with this one, and then I have B. So it's not L, not R, but it's B. So I return this to from here and initialize it. And initialize it. Yes, but here I still have L. So it should be like global iterator or something like this. Or pair. Okay, so what if I have int I is equal to 0 and everyone knows this one, and then I have this 0 here. Okay, so I have B, and here I just go next. So when I iterate from the left, so from here I have B or R, and here it's R, then go R, go left, then B, R, B, B, B. So yeah, so I don't need this one. And this one. Let's run. Here, if it's left, plus, plus. Okay. Index 0 outer bound x. Right. Let's run it first for this one. Expected 1, 2, 3. B return. R. Maybe this one. current okay, so yeah, I create my node value. So when I create, then I should update my current, and yeah, so I should increment it. Then I have my current. Then I have L, right? So when I have L, if current is L, then I should increment and make DFS for data. For this one, I make this one, this one, and I have B. So when I create 2, right, I own B, so it will be L. It's not R, but it's B. So I should increment it by 1 to R. And what next? So increment to R. If it's R, increment this one. Go. Okay, so I think I didn't solve it. So see you next time.